right. Hey, y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. I was about to post a video and I forgot. I had a brain fart about like the definition of the word bounded. So I was thinking, like, oh, because I'm normally thinking of bounded above or below by a limit. I was like, oh, wait. I was thinking it was unbounded, and it was not unbounded. It is bounded. It's actually bounded in like the strictest sense of the word. So that's why this one might end up being a little bit shorter. Let's jump in here. Number 33, sign of in. For each of the following sequences whose nth terms are indicated, state whether the sequence is bounded and whether it is eventually monotone, increasing or decreasing. So, sign is bounded. Bounded just means that it never goes above a certain finite value or below a certain finite value. So if it's bounded above, then it's, bounded above a certain minimum value. And if it's bounded below, then it's below a certain maximum value. This one would strictly just be bounded. So this one is just going to be bounded. And we could say that essentially it's bounded by what I wrote here. We know that it'll never reach 1 because in order for the sine wave to reach 1, it would have to be either pi halves, or the next time it does that would be pi halves plus 2 pi, which would be over here. This is 1 pi half, 2 pi half, 3 pi half, 4 pi half, 5 pi halves, aka pi halves plus 2 pi, or any multiple of 2 pi added to pi halves, which we would say is pi halves plus 2 pi k, where k is some sort of integer. Actually, not just an integer. In this case, it would be k is strictly a natural number, a whole number. Yeah, because the only values that are, along the intervals would be those values as we're going to infinity. Not that it matters too much, the nitty-gritty there. The nitty-gritty. But, yeah, so only if we have an in value that is irrational would we end up with the sign value equaling 1 exactly, because pi halves is an irrational number. It's a fraction, but it's irrational, because a rational number would have to be an integer over a whole number. No, over a natural number. If you take any integer and divide it by a natural number, you can get any number that is rational. So, but pi halves is not rational because pi is not rational. Pi is not an integer, and it is not. It's not an integer. It's 3.1415926. So it will never reach that number because we're counting by ones, right? In a sequence to infinity, we're counting by natural numbers. 1, 2, 3, 4, skip a few, 99, a million, and then infinity in that order. So it'll never reach 1. It's never going to reach 1. It's also never going to reach -1, and it's also never going to reach 0. Those particular values are very specific. It only touches the x-axis just for a brief moment. And it only goes to the max and the min for brief moments in time. All of those critical areas are all areas that have to be multiples of pi in some way. So the max value of 1 has to be a pi halves plus 2 pi k. The minimum value of -1 would have to be 3 pi halves plus 2 pi k. And all of the times that it reaches exactly 0 would have to be multiples of pi specifically. Any multiple of any, k multiple of pi. So 1 pi, 2 pi, 3 pi, 4 pi, etc., etc. And we're counting by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so on. So it's just never going to reach those particular numbers. So actually bounded, and there's a couple different ways you could write this, but we would say it's bounded. If we had to write it in interval notation, we would say it's bounded by from -1 to 0, and then from 0 to 1. I wrote it like this earlier, so you could also say something to that effect, that it's bounded between -1 and 0 non-inclusive, as well as from 0 to 1 in non-inclusive. Basically just writing out what I put in interval notation. So this is probably fine. This is how it's bounded. We're never going to have a sub n values that are numbers other than what are in these intervals. But it's not monotone. It's bounded, but it's not monotone. And I don't know how much explanation this one needs. Let me know if maybe this was insufficient, but it's a wave. So it's going to go up and then down and then up and then down. And it's doing that forever and ever and ever and ever and ever. It's never going to stop doing that. Now, waves in real life do eventually lose energy. I can't think of like an example where that wouldn't happen. I guess maybe like light, light as a wave as it's traveling through empty space. Perhaps that would not really lose momentum, so to speak. But if it's interrupted by a medium, then it could be, right? Like if you're in your room and you close the blinds or curtains or whatever, the light is still coming from the sun. You didn't stop the light coming from the sun. You just had enough of a medium to at least decrease the light that actually comes in through the windows. And then the walls are stopping the light from coming through as well. So, all kinds of things stop waves in their tracks or slow them down. Sound is another example. If I'm standing outside and there's somebody else standing outside, but they're really far away from me, if they whisper and they're like a football field away, I'm not going to hear them. That sound wave kind of just petered out because it's traveling through air and it loses energy into the atmosphere. So it just loses energy. So it would be going towards 0, but it still wouldn't be monotone because it's still going to increase a little, decrease a little, increase a little, decrease a little. So it's even then it wouldn't be monotone, but it would be going towards 0. So we actually would probably give the same exact answer, but it would look different if the wave were in real life. So anyways, I'm going to stop rambling. This is the answer that we're given for number 33. And hopefully that's been helpful. If you need more explanation, if your teacher needs more explanation, just let me know in the comments below kind of what they're looking for, and I can maybe make a follow-up video or maybe another follow-up video on this. And without further ado, go check out the 5 math mistakes everyone makes and how to avoid them. That is in the description below. And I'll catch y'all in the next video. Blessings, y'all.